Well, welcome to our structural modeling video conference for January 19th, 2019. Today we're going to be talking about augmented interactive management. Technical report number 25 from Systems Concepts that's out on ResearchGate. And we're going to walk through and kind of do a bit of a high-level overview of the components and a little bit of the history of interactive management and other parts of interactive management, what actually kind of fits in there. And at the end of this particular session, I'm going to display and show the GitLab open source software framework that I set up to support the development of the augmented interactive management concept. I have documented discussions, issues, and then start breaking down those functions from the many technical reports that we published on ResearchGate, and breaking those down into functions that need to go into software, and then we'll start implementing the software. And so we'll start making a connection between ResearchGate and GitLab and slowly moving forward on that. Okay, so today we're talking about and defining at a little more precise level interactive management and interpretive structural modeling and uniform program planning, which these were all kind of developed techniques over the years by John Warfield. We find that they've been essentially, in many cases, there's operations and functions from one or more of these very specific techniques have been mixed in ways that are non-standard. So what we wanted to point out here is that unified program planning was first, and it was based on the dimensions of the Hall's activity matrix, very clear here in large-scale program planning. In your program planning, you plan activities and processes. What do? You have problem definition, you have value system design. This is very important. System synthesis, systems analysis, optimization, decision making, and then planning for action. So these are the steps in the uniform program planning that Warfield drilled down to develop this process. And it identifies and describes the important interactions and definitions in between them. One of the key characteristics of a unified program planning is the interaction matrices, the self-interaction matrices, and then the cross-interaction matrices. So these are a key identifier of unified program planning among these other activities. And so if you are using a self-interaction matrix or a cross-interaction matrix, then you're using some type of unified program planning method. As we pointed out here, the major source of malformed ISM methods is the book Methodology for Large-Scale Systems, Sage 1977, which contains misinterpretations of the structure in complex systems of Warfield in 1974. So Sage was listed as one of the authors and reviewers of that book from Battelle. One of the unfortunate things that happened here was that the Structuring Complex Systems was a Battelle monograph that wasn't widely distributed, and the Methodology for Large-Scale Systems was published by a technical publisher and widely distributed. So there was definitely malformed methods were distributed and communicated very early on in the process. So IAM includes the ISM processes, which can be used in the IAM structuring ideas functions. So it's been my experience from communicating with people that are interested in structural modeling that there's many different methods and activities that are named ISM or IAM. And we need to kind of find somewhere where we can have a common definition of what are the functions and components, and then at least use that published authoritative description as a baseline that we can talk about, well, it's different this way, or it's kind of like this, but it's got that on it as well. Start establishing a common understanding. So interactive management, of course, was the last of the 3 structural modeling techniques to be developed, and it included aspects of UPP and ISM, and was an attempt to unify and organize and document many of these activities that were developed over a period of years by Warfield. And of course, these are 2 basic types of computer support are associated with IAM tasks. The first type, of course, just comprises user management, content management, and content presentation tasks. And these are things that are types of tasks and functions that would be associated with almost any type of software project. And the second type applies logical rules for detailed evaluation of a specific IAM task or phase. So we're looking at basically separating and modularizing the software functions in a way that we can clearly identify which task in IAM is associated with which software function. And of course, the interactive management phases is organized in 3 phases: planning phase, workshop phase, and follow-up phase. We go through here and detail these, and of course, IAM is grounded in managerial functions of intelligence, design, and choice. So the intelligence part is basically the empirical data and the empirical information that is required to support the activity that's going on is held within the group. And then once the group starts to communicate and learn and understand each other, then we have a kind of a design process going on. We have the opportunity for an expanded design or a different view of the problem. And then choice. And of course, the choice is, well, is this, is it really this way or is it really that way? The IAM processes are not completely deterministic. So there's lots of learning, there's lots of maybe new information that needs to be gathered, things like that. Of course, the planning phase is where you go through, organize what you're going to do, and tailor the process specifically to what the current sponsor or organizational broker's problems or focus is. So that these are where you take kind of a broad range of techniques, you tailor this for focus on a specific problem at hand. Then out of that planning phase comes the workshop. And in the workshop phase, of course, is where the ISM logical-based computer system is used. It doesn't appear that the ISM logical-based computer system is used in the planning phase. And in the follow-up phase, it can take many different forms depending upon the objective. And you can either have you can actually decide, well, we need to have more information, or we decided we have these 5 design alternatives we want to choose from. or we want to have a different project. These are the types of things that you do in the follow-up phase, but you can use many standard systems engineering, decision-making, and alternative analysis programs. But again, the ISM logic-based software doesn't appear to be used there in the follow-up phase. It appears to only be used in the workshop phase. So to get our
Joe, data point.
Oh, okay.
Cued by Ben Broom, we've found that the planning phase is best accomplished as an ISM workshop.
Okay.
Which includes the supposed sponsor of the forthcoming workshop and why they want to have one and what restrictions they don't want to be included. As we've, and I think the other facilitators that Warfield is licensed have that same notion that the planning phase is very, very critical and should be done. It can be better done using the ISM notions.
Okay, I think that's a good point, Jack. If we could get any more, get any more information on that, that'd be great, because that's kind of what this activity is for, is to design, is to identify these basic high-level steps and then gather different people's points of view about what it means and how they do it. And if we could get pointers, any documentation on that or how that works, then that would be great. We'll add it to the collective set of information.
Yeah, I'll see if I can dig up Ben Broom's paper when he was a Fulbright scholar and went to Crete.
Okay.
And to deal with the conflict between the Greeks and the non-Greeks. And it took him a year working just with some of the leaders in each faction to get them to the point that they would sponsor and support a workshop.
Okay, very good.
What he describes in that paper is how he took them through an interactive management session. Okay.
Good.
Same thing.
Look forward to that.
Same thing we find in the follow-up phase. The typical follow-up is action planning. And most people don't perceive that action planning can benefit from an IM process as well.
All right.
Anyway.
Well, again, we'll look forward to the more details on that and kind of expand it out as we go forward. That's kind of what this framework's for, is to do that and provide us a place to document and talk about more precisely what these phases are.
And what we think we're seeing, not sure at all, is that the success of action planning depends on how aware people are of category theory in activities.
Okay. Well, we'll have to kind of keep focused on that and look forward to expanding it out as part of this program. And so in the interactive management functions, we went through and listed the functions, what actually is interactive management designed to do. And as we can tell, they've got, the Science of Generic Design, Interactive Management Handbook, I guess, is one that lists 6 functions. I actually added the 7th function, which is selecting the preferred idea, because in their consensus methods, they list a selection consensus technique. So it seems like that they perform the selection process function, they just didn't have it listed. So in this particular case, it's generating ideas, clarifying or interpreting ideas, amending ideas, structuring ideas, interpreting idea structures, amending idea structures, and select the preferred idea. So we go through and look at these and get them a little bit more detail, because not only did they list the functions, but they also have some talk about the different techniques that are available to implement these functions. When they're generating ideas, of course, you have idea writing, but the nominal group technique and the Delphi process can also be used to generate ideas. No logical based software is required here, just standard types of computer-based network software can be used to implement these functions. Clarifying and interpreting ideas. So the nominal group technique is the general process. Generates ideas, clarifies ideas, supports idea structuring and interpretation, not to the level of ISM, but some. And the general NGT technique may be modified to achieve specific outcomes. So if you have certain types of activities you want to support, then it's possible to modify the nominal group technique some. In ISM, the Delphi process may also be used to clarify ideas. And then, of course, amending ideas, the Delphi process is used when required group members cannot meet at the same place and time. Delphi process is based on written communication from group members, which is coordinated by an administrative support team. Delphi may be used to generate, clarify, structure, and amend ideas and idea structures. NGT may also be used to amend ideas. So you can see that for these functions, you can have multiple different techniques that are available to perform the function. In structuring ideas, the interpretive structure modeling process is used by a group to structure and clarify ideas with the support of a specific logical software. So this is where the ISM logical software is used, and it provides an efficient mechanism to structure different types and is more efficient than Delphi and NGT because of the logic involved. Interpreting idea structures, the options field method process is used to structure and categorize design dimensions. And option field method is a sequence of 4 structuring events, each event based on the previous work. So this is kind of a method that people work through as they build structures and start to actually create design solution dimensions. And then amending idea structure, of course, is your options profile method. The process is used to create a design solution using a top-down design process. Be 1 or more steps. And then select the preferred idea. The trade-off analysis method is used to rate, rank, and choose a preferred option from the field of alternatives. ISM using a priority structure may be used to support, the trade-off analysis method and activities. So through these functions, we see that we have a number of different specific methods that can be applied. And I think it's important to be clear about what we're talking about, especially if we're going to start reducing these functions to software, so that we have software that helps us with these functions. The chart kind of shows the functions and the consensus methods. You can see 4, which is the interpretive structure modeling. Whoops, right here in the middle. So you start with ideas in number 1, and we have an output of the selected design solution. We can go through many different methods. And it seems like we need a combination of methods to go to go from 1 to 7. But most interesting is that methods 2, 3, and 4 all have common methods. And that that these may have ways, different characteristics and approaches that can be used to augment and support each other. So I think this is a very interesting chart. Shows many opportunities where an integrated software suite might really help. And when I was looking at this, of course, I was thinking that especially with the Delphi technique where you have folks that are distributed, they can't be in any one place and they're not identified, they're anonymous, they could actually be part of a local ISM if the ISM group itself was viewed as the administrative group. And so if the ISM group itself is the administrative group that's selecting and feeding back to the anonymous people that are answering, that to me kind of popped up as well. You know, we have the technology to do that. That might be a real advantage. It's just something to think about. But this chart, I think, has a lot, indicates a lot of potential. Of course, these are all the consensus methods that associated with IM. And so we go through and we talk about what the IM does. And then we talk about specifically what we're going to do to augment that interactive management process. And so the IM framework is augmented, augments the AIM framework. It augments the IM framework by focusing on minimizing resource consumption while fully supporting knowledge development and capture, so that we would now start applying software functions and network systems to increase efficiency in ways that are in addition to the logic, the computer logic. Of course, idea writing, that can be done in a number of different ways. Usually you have people together in the same room and they're passing physical pieces of paper. You could do that same thing in a distributed manner, using a network computing system, and you wouldn't maybe necessarily have to bring people into the same room. And there's a number of variations of idea writing that could be done in implemented network computing processing. In the nominal group technique, of course, is a method collective inquiry and learning. And these people now are kind of in the same room, and what needs to be really important here is the learning. And I think that Kevin is the one that emphasized the fact that people shouldn't vote until they discuss things. You're going to bring people together in a group. They should really discuss and inform each other about their different points of view and see if they can educate each other about their different points of view so that they can have an informed vote. And I'm sure that's not exactly what Kevin's point of view is. It's kind of my, very quick summary of it. But the idea, the difference, in my mind anyway, about the nominal group technique and let's say like Delphi or or idea writing, no one's talking to each other. And in Delphi, no, people are not talking to each other, they're just exchanging information. But here, it's much more group dialogue and interaction. Very important. So the key aspects here are how can you focus and minimize, well, can you focus these activities in a way that the group moves forward and develops valuable information and doesn't just chat about, you know, what a nice summer day it is and which football team is going to win next. So keeping the group focused on the issue of interest is very important. And so go through and kind of look at, and that's AIM framework provides a non-intrusive information collection and recording capabilities. So you can actually record all the interaction, look at later on, generate transcripts. You can do a number of different things with current level of computing technology. The Delphi technique is a method that has a range of interesting attributes and characteristics, but it's essentially a group where it has an administrative team that selects the problem of their interest, and we have anonymous people that are answering, and it's done asynchronously, and it's done in writing, and people, the members of the group don't even know who they are, so they're not talking or educating each other. So this is very interesting, and as I was thinking about this, it seems like that there might be a variation of this where you take the Delphi administrative team function and actually have that as part of the workshop teams function, where they would have not only local people that knew each other and were talking to each other, but then they had input from these anonymous experts.
Joe?
Yes.
Ken Lloyd is asking, how is anchoring error and confirmation bias overcome in the Delphi method?
Okay, so Ken Lloyd is asking, what was that again?
How is anchoring error and confirmation bias overcome in the Delphi method?
I'm not sure. Might be a very good process to go back and look at and see how that's done. I think I'm just simply off the top of my head, I'm not sure, and it would be a good thing to go and research. Technique's been around a long time, so we could definitely take a note of that. It's something that we want to discuss in the future. But as I was saying, it seems to me now that we could actually have some ways we might be able to integrate some of these functions. Then Kubernetes structural modeling, which is specifically a computer-assisted information structuring technique that enables groups to structure unstructured element sets. So now this is where the logical software classically is implemented, and other IAM functions must be used to generate and prepare for applications of the ISM technique. Key aspect is the requirement that the computer systems evaluation, you need to have this computer assistance. That's one of the trademark distinguishing, discriminating features of ISM. But a successful process will provide the correct balance of group learning dynamics and the selected computer algorithm. So there's kind of like the group learning in NGT, but using the computer algorithm to help you guide where the group is going. And so there's a warning, of course, it says that you need to make sure that you have skilled process leadership, which must facilitate the process rather than become involved in the issue. And overemphasis on the mechanistic and technical aspects of the process during its use is highly undesirable, while underestimation of the significance of its behavioral attributes by the facilitator may significantly weaken its utility. So what we have here is we're applying some techniques, trying to increase the efficiency of the MGT technique and still maintain the benefits. And so there's a balance. You have to figure out where, where that specific value structure is. And of course, this concept was initially emphasized in the first edition of the Handbook of Interactive Management. The emphasis that's groups, other groups that are practicing IM, place on the use of highly trained facilitators, usually much less than is done in IM. Some of those organizations actually see the computer as the group facilitator. In contrast, in IM, the computer is seen as a significant aid to the IM facilitator. And what we're adding with augmented IM, the computing processes and so forth, are all seen as aids to the facilitator and the people that are managing the process. The computer program is not managing the process. It's simply being designed to increase efficiency by reducing the effort for documentation and reducing the effort it takes for the logic, of course, but also recording all of the activities that are going on in a non-intrusive way. So you just record what people do. You won't really require that people have to type into a keyboard or things like that if they don't want to. Today, most people are very skilled with computing technology and may prefer to communicate using a computer, but they won't be forced to. So,
Joe?
Sure, Jack.
At this point, you haven't mentioned spread think and group think and clan think. John emphasized early up here in the game, and before you start your interpretive structural modeling, that it's important to compute specifically the spread think index of all the ideas generated, so that you can detect whether or not the group that you're working with is opposed to arriving at a mutual ideas.
Yeah, so that's true, Jack. I think the metrics, we're looking at the complexity metrics and the situation metrics that can be computed once we have a specific set of people in a specific context. And right, I haven't done that because I want to just use the IM and the science of generic design, the functions that were listed there and the methods that were listed there as the foundation for saying, identifying the attributes and characteristics of what these different methods are. And so, so this is just identification of what these specific listed functions and methods allocations are.
It's too late. It's too late.
We can definitely do that next.
The spread think index should be calculated as soon as the nominal group technique has got the idea writing all on the board. Because at that point, you can determine whether or not the various participants are amenable to new ideas or not.
Well, that's really good information, Jack, and I think that it's it's important that be done. And I think that what we need to do is in the next write-up and more detailed write-up of this, we need to add those things. Right now at the higher level, what we've been able to do now is we've created this framework that says, oh, this is idea writing, this is nominal group technique, this is Delphi, this is ISM, these are these methods. And now we can say, oh, spread think and these things should be done right here between idea writing and normal group technique. So,
what I'm saying is that it requires some computer assistance to compute the spread think index.
okay, good.
So that is a feature of your tool that I think should be mentioned.
Okay, we will add that. I appreciate that, Jeff. And I think that as we go through, we will make sure that we pick up all of these specific functions and ideas. We're just getting started now. And so, as it says here, in the last 25 years, computer technology is ubiquitous. It's everywhere. And so it seems like there's some ways that we should be able to use that. The options field is very interesting, and the options field method and the options profile method as a way of defining and structuring spaces for suitable designs and acceptable designs. And it's an iterative type of process that you go through. Again, we haven't gone into these computer support activities in any detail at all here. There's a number of very specific methods that will be needed to compute the options field method, as like Jack talked about with the spread think and group think. So there are lower level methods and techniques that we haven't highlighted here. We're just doing the big framework. And the trade-off analysis method, again, is used to select the preferred alternative. And of course, from this, you have to do a value system, prioritize your values, do a number of design choices and so forth. And there's many software functions to do that. Some are classical systems engineering approaches. Others are not. And if you took, for example, and implemented a group of these techniques into a tapestry or a type of quads that takes a number of these techniques and organizes them together, then what you would have is a set of integrated methods that would allow you to rate and rank possible outcomes from your design. We didn't go into the quads, didn't go into the tapestries because they weren't listed as functions, but they would be an integrated part of this. And unlike the software functions that drill down into a little more detail, then the quads and the tapestries kind of sit on top and integrate these activities, and they themselves will have their own software management function. So there's things at a higher level of abstraction, there's things at a lower level. We just started here because these were the functions and the methods that were listed in either the Science of Generic Design or the Handbook of Interactive Management. Give us a basis. So for information management, well, and I think the whole idea here is to just start identifying software functions that can make this process more reasonable, make it more efficient. We have gone through and developed open source software that we designed that is kind of a proof of concept and actually reproduces the outcomes generated by the GMU ISM software, as documented in Appendix 2 of the Handbook of Interactive Management. Put that together. The primary problem, and as I said earlier, people that are writing software to support ISM, people that are studying in all different fields, they've made comments about this, but the idea is that there's many different kinds of methods and activities that are called ISM. And so what we really need to do is establish some touchstone that says, okay, these are the functions, these are the methods, and then these are the sub-methods and techniques that implement them. So we can start talking about more precisely about what group of functions and what people are doing and why they're doing it, and not just calling it ISM, because just by naming something ISM, is the name has been the namespace has been polluted to the point where it's almost impossible to tell what people are talking about. And of course, the ISM logic example that we use here, we have the idea in the Handbook of Interactive Management. We did our proof of concept software that was able to go ahead and reproduce that. But what we found is that we weren't able to reproduce all of the many outcomes that were published in the literature. And so this is kind of concerning to us for a while. We kind of thought about that. But what we found is it creates a situation where only structuring relationships with the global, irreflexive, asymmetric, and transitive logical attributes and properties may be addressed correctly with our current open source software. And so Mary and I worked on and developed the augmented interactive management. The augmented model exchange isomorphism that went through and put the 27 logical groups together, outlined those, and out of those we found that really Warfield's text, when he was writing down in text, only referred to about 4 of these 27 groups. And the graphics, the structured graphics that he produced, really only addressed about 7 of these groups. So,
Joe,
yes.
In the second paragraph, you use the word repeatable verified outcome. Do you mean use of the algorithm that is not stochastic? It doesn't, to be able to use it in a way that doesn't depend on the order of the pairwise comparisons or pairwise juxtapositions?
Yes, and that's so what it is. It's what we did when we tested our software. We took of course, we tested that we were able to reproduce what was in the input sequence that was done in Appendix 2, right? But then we randomized the inputs, right? Randomized those. So we said, okay, if this is the structure, this model only has one structure, right? So you should not get a different answer depending upon your the sequence in which you get the answers. So that's what we mean. We'll talk about that a little bit more in a minute. So we said, well, okay, looked at that a little bit more, and then we defined the idea of a local relationship and a global relationship. And it's looking like to us that right now that the local relationship really refers more to an intransitive relationship, and a global relationship actually refers to a transitive relationship. And further, there's certain characteristics about the graphics, and there's certain characteristics about the natural language relationships that help to that might help us find a different way to optimize the selection of the structure, but with a different generic question form. So what we're proposing is that we have now 2 types of generic questions, and that generic question, the reason that you pick one or the other depends upon the logical structure that is outlined in the AMEI. There's some indication I haven't been able to think about it, hadn't enough time to think about it in detail, but there might be a couple of more types of question forms. that might be applicable, but we'll see. Those might also just break back down and also might be just used as these two. I haven't worked them out yet. But so what happens here, of course, is in the original generic form, you have in the generic question form, does X precede Y when you're looking at precedes? Well, precedes is irreflexive, asymmetric, and transitive. And when you ask that question, and you have this group of objects you really don't know, you'll say, you could randomly select and say, well, does A precede G? And the answer is yes. You say, does A precede J? And the answer is yes. Does A precede B? Yeah, the answer is yes, right? So that there are multiple positive answers if you pick A. You pick J, you say, does J precede A? Well, no. Does J precede E? Well, no. So that and there's also, depending on the element you pick, there's multiple negative answers. Right? So that this is definitely a transitive relationship. A precedes B, E precedes C. That means A precedes C. And one of the problems, or one of the issues with the way we draw these structured graphics is we don't put the transitive links in by convention. Transitive link would have a link that goes from A to C, B to D, C to E, right? But those are not shown, and they're not shown because they clutter the graphics too much. So because we don't put the transitive arrows in, there's no graphic indication of whether it's transitive or intransitive. So we take a look now at the reports to natural language relationship. As you can see here, there are multiple structural threads running through the reports to hierarchy. And the ISM logic support software is used to reduce the number of generic questions needed to complete a structural model. So we now kind of change the question for reports to, when we say, who does someone report to? Because as we can see here, Larry reports to Bob, Bob reports to Bill. Larry does not report to Bill. This is intransitive. Sam reports to Pete, Pete reports to Sue. Sam does not report to Sue. So this is an intransitive relationship. And of course, it's one of the relationships that's used within the ISM structure where they all need to be transitive. And so in our particular case, in this particular case, for this particular relationship, if you just ask, who does Sam report to? Because Sam only reports to one person. Now, multiple people can report to the same person, but you only report to one. So that now we would use the augmented ISM software to say, well, okay, we'll just keep track of these answers and draw the structure. There's nothing to infer. The only thing to do is to keep track and make sure that, okay, I've got an answer from everybody, and then draw the picture. There's no inference capable here because it's not transitive, but it is, software still has the capability of enhancing the efficiency. So you now have two types of generic questions based on the logical property groups associated with a natural language relationship. They said, I think there might be more, but that's something we'll be working on as we go forward. So if we go through here, it says, instead of asking the question, does Sam report to Larry, the question should be, who does Sam report to? Because the empirical information is in the group. You know, the idea of using the software to reduce the cost and time and effort to basically get that information from the group. So, yeah, logical inference may or may not be used to guide the empirical inquiry, but we're also able to get to a point where we can increase efficiency and reduce the effort. So, in summary, structural modeling is a powerful technique with a long history of actually engaging complex situations of all kinds. And the current literature is littered with various different methods. So we've talked about what they are and how we can identify the difference between them. Using the AME logical groups to rate and rank, make a distinction between natural language relationships, put those together. And that's going to be an area of focus in our, as we go forward. And we will be talking about this again during the February 2nd, I think. Take a check here, February 2nd. Structural modeling, February 2nd. Yeah, February 2nd conference. We'll be going into a little more detail about not only these functions, but also specifically how we would map those across into software functions. So one of the things I'd like to share next is the just briefly is our need to find it here. Okay. No, well, doggone it. Oh, here it is, right here. Okay, share this. All right. Everybody should be seeing a GitLab thing that says AIM, AIM on it. And I put I've created a GitLab open source project. This is open to the public. And it is an area where we'll be working the requirements, working the issues. Here's the issue queue over here. Whoops, I can't do it on that screen. I got to bring it over here. So this is the issue queue right here. I have done a simple set description and issue templates for this group. Put that together. I also have a wiki. Come on. Here we go. Here's a wiki. And the wiki will be used to translate and pointers between the more theoretical, high-level overview papers that are technical reports that are on ResearchGate, and then the specific reduction to software and how we're going to do that. That discussion will probably take place here on the wiki because it won't be to the level of a technical report, but it will be referring back and forth through the ResearchGate publication and here. So this is just started. I will send this link out with the end of the meeting report. It's just the start. It will improve over time. With that, is there any question? All right. Well,
I wanted to mention before they came up with the 7 consensus methods, there was an evaluation of somewhere between 50 and 70 methods in the early 70s. This was in the 60s. There was this flurry or proliferation of methods, like design methods, published by John Chris Jones, was an encyclopedia of different methods, everything from creativity techniques like brainstorming and nominal group technique to more structured things and group processes, and it's kind of a mishmash of everything. And there's a lot of things that look like the work of charlatans. There, a lot of publications that just didn't have basic evidence or literature, but people were making all kinds of claims, which is kind of what brainstorming did in the 50s. They made a bunch of unsubstantiated claims, and they were disproved through experiment within 6 years. And so in the early 70s, Warfield and Ozbakan and Christakis and some others, I think is when they were at Battelle, they went through an evaluation of like 60 processes, and they had a set of criteria, about 12 criteria, by which they would evaluate all these processes. And this is a story told to me, and I was shown, I have somewhere in my archives presentation material about this selection process for the 7 consensus methods that they went through. But I don't think it was ever published how they went about doing it. And it seems to me, and this is the early 70s, it seems there's been, 40, 50 years of methods development since then. And we should go back through that. I think that one of the things in the work I've been doing in Cyprus with the report I showed you last time is we were looking at, there's a huge number of methods for the front end or the planning phase, the prep phase. For example, most things that you're going to do an interactive management session about, something's been written about it. There's opinions already out there, usually just a huge amount of material. There's kind of a presumption in the way Warfield wrote about things that there's no literature about anything you're doing until IM enters the scene and you start planning the process, and then like no data comes into it until people are in the room. But there's, usually there's a huge body of literature, and how do you summarize all that in a cost-effective way? Well, there's a lot of tools for doing that, and no one's gone through in a comprehensive way and say, here's the new set of recommended consensus methods. And one of the principles should be it's been validated by some type of evidence. There's some type of statistics about its use, something that kind of drives the quality and the legitimacy of processes. I think so. That's just something I thought we might think of revisiting.
Yeah, I think that's great, Kevin. We've got just a couple minutes left, the augmented interactive management approach. One of the reasons for the additional software support is to not only identify and look at these different knowledge sources, but to be able to bring them in, analyze them. There's many different techniques that are going on out there now with large big data, many tools that are available, so we can inform the group on many different levels. So there's I agree with you 100% on that, but that needs to be a focus. If you are working on that and would like to keep doing it and kind of let the group know what's going on, that'd be great. I'm going to be working on, as I said, developing the software functions, putting it out in open source, see if people are interested, and kind of go forward from there. How's Janet today?
How are you today?
Like today?
Fine.
Busy.
Oh, Janet Singer.
All right.
Yeah, glad to be able to, come in here a bit. We will. I'm not sure if we'll be able to do every month, but a little bit more time.
Well, good. Excellent. Well, we're going to be doing again on February 2nd, and we will be updating the GitHub as we go forward, if communicating a little bit more to the group about what that's going to be, what kind of resource it'll be, and go forward from there. So
Very
with
good.
that, if there's no questions, did you say something, Janet?
No, I just said very good and good to see everybody and hear what's going on.
Okay, excellent. Well, we'll see everybody on the 2nd. Take care, have fun.
Thanks to all. Take care in the snow.